Ever get that feeling? You know that feeling like time might be less like a straight line and more like a looping track? Well, buckle up because today we're diving deep, really deep,
Right.
into the work of Edson Schenkel. And let me tell you, he's got some ideas about time that are, well, let's just say they'll make you question everything you thought you knew.
It's true, Schenkel's work isn't for the faint of heart.
Not at all. We're talking about the possibility of time being a circle, not a line. And to help us navigate this mind-bending journey, we've got our expert. So time is a circle. Where do we even start with that?
Well, Schenkel starts with something familiar, Einstein's theory of relativity. Einstein showed us that time isn't this rigid, unchanging thing. It's actually affected by speed and gravity.
Okay, that rings a bell.
Right, but Schenkel takes this idea and just runs with it. He asks, what if we've been picturing time wrong this whole time? Instead of a line, what if time is actually a circle and the Big Bang? Just one point on this infinite loop.
Whoa, okay. This is where things get really interesting. Schenkel's basically challenging the very way we think about time. So how does this circular time actually work? Paint us a picture.
Imagine a series of concentric circles like those, like a multi-layered cake.
Okay, I'm with you.
Each layer represents a different energy level in the universe. Objects, depending on their mass and how fast they're moving, they kind of hop between these layers. They move to faster or slower time circles.
Okay, I'm trying to wrap my head around this. So what would it actually look like for, let's say, a rocket ship to move to a different time circle?
Okay, so think of it this way. As that rocket burns fuel to escape Earth's gravity, it's essentially using energy to leap to a different time circle. It's like jumping to a different layer on that cosmic cake, a layer where time flows differently. And that's what leads us to some, well, seriously wild implications. We're talking time travel.
Time travel. Okay, now we're going down the rabbit hole. So is Schenkel saying Doc Brown was onto something with that whole flux capacitor idea?
Well, Schenkel believes that time travel might actually be possible in a circular time model, but, and this is a big but, there are some major caveats. He even proposes a method using focused energy to transition between these time circles.
Hold on. He's actually suggesting a way to time travel. What would that even look like?
Well, he's very cautious about it, emphasizes the potential dangers, especially if you don't get those calculations exactly right. Imagine someone from, like, way back when, suddenly yanked into the present just because someone flipped the switch on a time machine without thinking it through.
Okay, yeah. Maybe leave the time travel experiments to the theoretical physicists for now. But time travel aside, what other mysteries might this circular model help us understand?
See, that's what's so intriguing about Schenkel's work. He doesn't stop at time travel. He suggests that this whole circular time idea could shed light on one of the biggest enigmas in modern physics, dark matter and energy.
Now we're talking. This is where it gets really interesting. Tell me more.
Remember those concentric time circles, our cosmic cake?
Yep, got it.
Schenkel proposes that what we perceive as dark matter and energy, it might actually be the unmeasured mass of particles that exist on different time circles. They're out there interacting with our own in ways we don't fully grasp.
Unmeasured mass. Okay, we need to unpack that a little. What does that even mean, and how does it relate to dark matter?
Think of it this way. Imagine you're trying to weigh something, but it keeps flickering, like visible, invisible, visible, invisible.
Trippy.
Right. You might get a reading, but it wouldn't be accurate, right? Because you're only catching glimpses.
I see. So it's like it's not really there, or at least not all the time.
That's kind of what's happening with dark matter. It's there, it's exerting this gravitational pull, but it doesn't interact with light in a way we can easily detect.
So it's like a cosmic game of hide and seek.
In a way, yeah. Schenkel suggesting that these particles aren't just invisible to our instruments. They're essentially on different timelines, different slices of our cosmic cake, only occasionally bumping into our own. And because we can't directly observe them or measure them in those other time circles, well, their mass remains unmeasured to us.
That's wild. So these particles are out there zipping around on their own time circles, and we're just catching glimpses of their influence through their gravity.
Exactly. And it gets even more mind-boggling. Schenkel suggests looking for tiny discrepancies, little hiccups in energy and momentum in the particles we can observe. He even calculates what the mass of, say, an electron would be if it were spread out across the observable universe.
Wait, whoa, hold on. We're talking about potentially enormous amounts of hidden mass here, right?
Potentially, yes. And it's all because these particles are existing on different time circles, interacting with our own in subtle, often undetectable ways.
My brain is officially doing backflips. Okay, so we've got time travel, a potential explanation for dark matter. What else can this circular time model help us understand? Okay, so we've got time travel, a possible explanation for dark matter. What else can this circular time model help us understand?
Well, Schenkel doesn't stop there. He sees connections to superconductivity, too.
Superconductivity. Okay, remind me again. What's superconductivity?
So superconductivity, it's the ability of some materials, right, to conduct electricity, but with zero resistance. And this usually happens at really, really low
Oh,
temperatures.
right, right. Like those super efficient power grids they're always talking about in like futuristic sci-fi movies.
Yeah, exactly. And Schenkel, he thinks superconductivity might actually be connected to this whole circular time idea. He suggests that it's all about electrons, right? But they're achieving this stable, low energy state, and get this, within their time circles.
Okay, I'm going to need a little help visualizing this. What does it even look like for an electron to be stable in its time circle? And how does that even relate to superconductivity?
Okay, so picture those concentric time circles again. Got 'em.
Yep, still with you.
Okay, so now imagine the electrons. They're usually zipping around these circles, right? But there's a bit of friction. Like, imagine a ball bouncing on a bumpy road.
Okay, I can picture that.
And that friction, that's the resistance. It's what causes energy loss in normal electrical conductors.
Yeah, makes sense. So where does superconductivity fit into all of this?
Schenkel suggests that when something becomes superconductive, it means those electrons, they've found a smooth path, right, within their time circle. They're not bouncing around all haphazardly anymore. They're flowing smoothly, almost effortlessly, like, say, a ball rolling on a perfectly smooth surface. And this smooth flow with barely any friction, that's what makes superconductivity so efficient.
So are you saying that by tapping into this smooth flow of electrons within their time circles, we could revolutionize how we transmit energy and more?
Exactly. And that's just one example, right? We've only really scratched the surface here. Schenkel, he doesn't shy away from applying these ideas to some of the biggest questions we have, like how did the universe even begin?
Oh, wow. Okay, yeah, this is where things get, like, really philosophical. I'm intrigued.
I know, right? Schenkel's model, it challenges that traditional linear view of the Big Bang, as the absolute beginning of everything. He's proposing instead that it could just be one point on a loop, a cycle of expansion and contraction that just keeps repeating.
So instead of a universe with, like, a hard start and a hard finish, it's more like, what? It's breathing,
Yeah.
expanding and contracting over and over.
Mm.
That's a pretty big shift in how we usually think about it.
Absolutely. And it doesn't even stop there. He even explores consciousness through this lens of circular time, even touches on the idea of, like, a higher power.
Consciousness and, like, a higher power. Yeah. Through the lens of physics. I did not see that coming.
Right. It's pretty wild stuff. But Schenkel's work really pushes us to think beyond the traditional boundaries. He's suggesting that our individual consciousnesses, they're like these localized points of awareness, right? But we exist within this vast, interconnected web of energy, all operating within this circular time.
So we're all connected, like, through this web.
That's the idea. I imagine every single consciousness is like a node in this enormous network, all these different points interacting and influencing each other. And because time's a circle, well, that allows for a much deeper level of interconnectedness than we could ever imagine in a linear model.
Wow, that's a lot to take in. It's kind of humbling, honestly, to think of our own experiences as this small part of something so much bigger, something that goes way beyond how we usually see time.
Hmm.
It really makes you wonder, what else is out there to discover, especially if we can break free from our assumptions about how the universe works.
Exactly. And that's what's so exciting about Schenkel's work. He might not have all the answers, but he's opening up these amazing new paths to explore. It's like he's handed us a map to a whole universe of possibilities.
It's like we've stepped into a whole new dimension of thought with this.
That's the beauty of Schenkel's work, isn't it? It's like he's encouraging us to consider perspectives we might never have even thought of otherwise.
Yeah, totally.
And even if some of these ideas seem a bit out there, like we're on the fringes of science fiction.
A little bit, yeah.
Even if we can't fully grasp the science behind it just yet, there's something about considering these alternative possibilities that's just, well, captivating.
Absolutely. It really speaks to that very human need to understand not just how the universe works, but why. The big questions, right?
Exactly. And maybe, just maybe, as Schenkel suggests, the answers to those big why questions are hidden within the nature of time itself.
Okay, so you're saying the key to it all is figuring out how time really works.
It's a possibility. Think about it. By even just exploring the idea that time operates differently than we think it does, we might be opening ourselves up to a whole new level of understanding.
I like how that sounds. It makes me think about what you were saying earlier about Schenkel's ideas challenging that traditional view of the Big Bang,
Yeah.
as this definitive starting point. If time really is a circle, does it even make sense to talk about a beginning or an end?
That's something Schenkel wrestles with a lot in his work.
Hmm.
See, if we can imagine time as this circle, then every single point on that circle is both a beginning and an end. All depends on how you look at it, right?
Whoa. Okay, that's a bit of a mind bender.
It is. It's hard for us to wrap our heads around because we're so used to thinking in a linear way.
Yeah, like trying to find the edge of a sphere, right? It
Yeah.
doesn't really work that way.
Exactly. It's a totally different way of thinking about things. And honestly, that's what makes Schenkel's work so compelling. He's not afraid to challenge us, to make us step outside of our comfort zones, to embrace the unknown, and approach these big questions about the universe with fresh eyes, with a sense of wonder.
That's a great point to end on. It's in Schenkel's ideas about circular time. Definitely not easy to understand, that's for sure. But man, do they make you think. They encourage us to really examine what we think we know about the universe, to be open to new possibilities, to maybe even see ourselves and our place in the grand scheme of things a little differently. Who knows what amazing discoveries await us as we keep exploring this mind-blowing idea of circular time.